All right, so what we're going to be going through is we're going to be going through Chapter 9. So let's start off with this warm-up. So remember, these are your diamond problems, which you're going to do multiply to get the top number, added to get the bottom number. Okay, so take a minute to answer these. You can pause the video if needed to answer these two problems. Okay, so with our diamond problems, remember we multiply to get the top and add it to get the bottom. So when we multiply the two top numbers, we end up with a negative 63 and we end up with a positive 2. Okay, so you multiply 9 and negative 7 for the top and then you add them to get the bottom. The second one, when you multiply them, you end up with 50, and when you subtract or when you add them together, you end up with 15. So that's your diamond problems that you have. Okay. All right, so let's move on to our chapter, which is Chapter 9, Section 1 of Algebra 1. So we're going to be adding and subtracting polynomials. So we're going to be discussing what a polynomial is and then how we add and subtract them. So the first thing up is what a polynomial is. So basically what a polynomial is a polynomial means many numbers or many numerals. So it's something that has multiple, what we would call terms. So we're going to be calling them terms. We're going to look into detail what those are on the next slide. But we're going to be looking at things that have multiple terms. Now, the basic rule when you have these polynomials is that when you combine them, they have to be exactly the same. Okay? The variables have to be the same. So if we look at the three examples we have below, we can combine 4x plus 2x. 4x plus 2x would end up being 6x. Okay, we don't change the power or anything, but we can combine them because they both have 1x. The next example where we have 4x plus 4x squared, we wouldn't be able to combine because one is x and the other one's x squared. Okay, so x and x squareds are different and we won't be able to combine them. And this last example we also wouldn't be able to combine because, as you see, it's 5x plus 6xy. The second one has a y attached to it and the first one doesn't, so we wouldn't be able to combine them because they are different. Okay, so they got to be exactly the same for you to be able to combine them. Okay. All right, so let's talk about what a term is now. So what a term is basically this example right here and what we saw on the previous slide. 5x squared would be considered a term. That entire thing would be a term. Okay. Now, inside of a term, we have two different parts. We have our coefficient and we have our variable. Our coefficient is the number that's out front. Now, this number could be just 5, it could be 7, it could be 18, or it could be a number that, or a letter that represents a number, like pi, or Euler's number, or phi. Okay, all those represent an actual number. Okay, guys, think about moles and different things. Okay, so they represent something. That's your coefficient, so it's a number. Okay, now as you move on in algebra and other levels of mathematics, we end up putting variables in there because we want to solve them, but that's a discussion for a different time. The other part is your variable, which is your x, your y, and your exponent. So whatever the variable is that's floating around your problem, that is the variable. So if I had an example of like 6x cubed y to the fourth, okay, that would be a term. That whole thing would be considered a term. My coefficient would be the part that I'm underlining, the 6, while your variable would be everything in the box. So 3x, or x cubed plus y to the fourth, would be considered your variable. Okay. All right, so now combining like terms. Again, when you're combining like terms, you want to put it in what's called standard form. And standard form is kind of like, this is how we want to write it because then everybody knows what we're talking about. And so what we want to do is we want to combine all the x squareds, all the x's, and then all the constants, or the numbers that don't have anything, don't have any variable. But we want to keep them separate because we don't want them to be the same. So if we look at this first example, we would just start adding our numbers. So we have 7x squared plus 9x squared plus 6x squared. So we'd add all those up, and then we'd get our number. So 7 plus 9 plus 6 is 21. Okay, 22 should be 22. 22. And then we would combine our x's. So then we combine this negative 7x and this 6x. Okay, so we combine those, and we end up with our minus x, or minus 1x, and then that 9 is all by itself, so we don't have to combine it. Okay, so we have our numbers, and we combine it, and this would be written in standard form. As you see, the exponents decrease by 1 going down. So we have our largest exponent as that 2, and then we have the exponent of 1, and then we have the exponent of nothing, or 0, and it goes down. Okay, so take a second to answer this second one, simplify it down so you get it down to a single answer. Okay, so when you simplified it, hopefully you got negative 15x squared plus 9x plus 17. Because the x squareds combined, they're both negative 8 and negative 7, get you a negative 15. The 9x is all by itself, and then the 8 and 9 are added to get you 17. Okay, so that's combining like terms and writing it from standard form, which is greatest exponent to least. Now, with these polynomials, we end up having names for them, and there's specific things we have. So the first thing is the degree. Now, the degree is going to be the highest exponent in the problem. So the higher the exponent, the different name it has. If it's a degree of 0, it'd be considered a constant. Okay, and the example of that would be 5. If it's got a degree of 1, so the largest exponent floating around is a 1, that's attached to the variable, is 1, then it's linear. So like 3x plus 9. That would be considered a linear equation because when you graph it, it's a line. Next one's a quadratic, which means a power of 2, cubic for a power of 3, quartic for a power of 4, quintic for a power of 5. Anything bigger, so like if you have a sixth degree, you would just say it's a 6th degree polynomial. Okay, you don't need a specific name for it. It's not going to be a problem at all if you just go, oh, 18th degree polynomial. Okay. The other way we can name it, except for besides the degrees, is you can also name it based on the terms. The more terms it has, you use a different name for it. So if there's only one term, so like the top example, we have 5, that only has one term in it, we call that a monomial. Okay, monomial basically means one number. Next one we have 2. 3x plus 9 has 2 terms, so we call that a binomial, like a bicycle. Okay, that means you have 2. Next one has 3 terms, so we call that a trinomial. Tripod, tricycle. Okay, it's got 3. And then if we look down here, we have polynomial. Anytime you have 4 or more terms, you would call that a polynomial. Okay, we're not going to use any other specific names beyond that. We just call it a polynomial. So if there's 4 terms, you call it a polynomial. 8 terms, call it a polynomial. Okay, basically just means multiple of it. Okay, so this is something you probably want to write down and have for future reference. Okay, so one thing you want to do before you start naming them is that you want to simplify it all the way down. So you want to simplify the equation before you start naming them because it could change. So if we look at this example, and if we were to try to name it, what we want to do first is that we want to combine like terms. So we see we have x cubed, and x cubed. Well, 4x cubed minus 7x cubed plus 3x cubed gets us 0. So you see that x cubed ends up disappearing, leaving us with 8x squared plus 9x minus 8. So now we would name it based on just that information once we simplified it. So you see originally we had a polynomial, more than 3 terms, and it was cubic because our largest power was 3. But after we've simplified it now, we see that that cubic has now turned into a quadratic, and the terms have gone from a polynomial all the way down to a trinomial. So once you simplify it, it's going to change, and you've got to make sure that you do that. Okay, so make sure you simplify before you name. Okay, so take a second, pause the video, and you can answer these following. Name them both by their degree, so constant, linear, quadratic, cubic, and name it based on their terms. So make sure you simplify before you name. Okay, so with this first one, once we have this, we would name it, it's a cubic trinomial. Okay, you see it doesn't combine anywhere. We have 3 terms, that's our trinomial, and the largest power is 3, making it cubic. Now on our second one, we see we can combine that 4x squared and that negative 7x squared. So we combine those, and then we see we end up with a trinomial, but it's only quadratic now. Because since these combined, okay, since those combined, we're down to only 3 terms, and then we have our quadratic because the largest power is 2. Okay, so your homework from this section is section 1. Okay, make sure you work on those and get it done. Okay, and wait for the next video.